part of my research about history of astronomy. And a special thanks to Dr. Rahimi and Dr. Italian who gave me this opportunity. This lecture is a combination of astronomy and history, in fact, cultural exchange between the East and West, and the impact that astronomy from, in fact, the theories of astronomy that was developed in Iran and neighboring countries, how they impacted the pre-modern astronomy in Europe. According to most of the historians of science and historians, the beginning of scientific revolution started with a revolution in astronomy. In fact, in 1543, a major book was published by Copernicus. The name of the book was De Revolutionibus Orbium Coelestium, or about the revolution of, or the motion of spheres. There, Copernicus introduced a new model. That model was a heliocentric model. Before Copernicus, most of the people, or majority of people, believed that the Earth was the center of the universe and everything was moving around the central Earth. It was Copernicus' new model that he put the sun at the center and the Earth revolving around the central sun. This is what we have learned from scientific books and or education. However, the previous model was the geocentric model. This Earth is at the center and all planets and stars moving around the center of Earth. This is very, very close to our common sense. We don't feel any motion. So every day we see that the sun rises from the east and sets in the west, and night sky we see all the stars are moving around us. And the previous picture, I'm sorry, this is that we don't have any clue that we are moving around the sun based on our daily experience. But this picture is very close to our experience and our common sense. This revolution, which happened in 1543 and took a long time people to acknowledge it and, in fact, produce new theories based on these heliocentric models, was a revolution that started the scientific revolution. In fact, it changed everything in our culture, in our epistemology, in our philosophy, and all understanding that we had about nature. These are a simplified presentation of Copernicus model and the previous model, the Earth-centered model, which is geocentric model and mostly is known as Ptolemy's model. Ptolemy was an astronomer in 2nd century AD from Egypt, and in fact in Hellenistic culture. And if you just compare them, you will see that if you change the place of the Earth and the Sun, the rest of the planets are almost the same. Saturn is the last planet that we know. Jupiter is the second from the end. Mars is here, and here we have Sun, but just change the position of the Sun with the Earth in the third orbit, and then everything becomes reversed, and then sun is at the center here, and comparing to this model, Earth is at the center of this model. Again, I emphasize on this that this model is very close to our common sense and our experience, and this is, we need a lot of evidence to prove it. In fact, after Copernicus, it took almost 100-some years to prove this, the validity of this theory. So the question is this: why did Copernicus change this system of the world? What was the problem? In most of this, in fact, popular science writings, we imagine that scientists are some crazy people. Just overnight, they decide something or they discover something, and all of a sudden produce a new theory. It is not in fact, a realistic presentation of scientific activities. So we have to discover what happened for Copernicus, what was the background, and Copernicus came with this new model. Here I have to go to astronomy. I'm sorry, I promised to make this astronomical part of this lecture very short. The base of classical astronomy was centrality of the Earth and the uniform circular motions of all heavenly bodies around the central Earth. As I explained, it is based on our common sense, and we have a lot of evidence that all of them are moving around us. In 300 BC, Aristotle made these two concepts as his the basics of his philosophy. He created a very well-structured cosmology, and in fact, he explained the entire universe based on these two basic concepts. So after Aristotle, 300 BC up to 16, 1700s, this was the most dominant philosophy and cosmology everywhere that we had education in this world. In the Middle East, in Europe, and even in India, we had the transmission of Greek science to India. So this was the most acceptable picture of the universe. However, from the time of Aristotle, or before, long before Aristotle, people knew that some of the motions were not regular. For example, if we count the number of days in spring, in summer, and fall and winter, we will find that the number of days are not equal. So, spring is 94 and a half days, summer is 92 and a half days, and fall is 88 and 1/8 of days, and winter is 90 and 1/8 of days. So, if I'll show you how did they discover this. If it is the case and we observe it, we have calculations and we cannot deny it, then we can imagine that we are at the center of the universe, but the motion of the sun around us, which creates this seasons, is a little off center. So we have sun here moving around the Earth, but it is not exactly the position of the center of the sun is not with Earth. So this is the line that shows the diameter of the sun's path, and here is the center of sun's motion, sun's circle, which is not the same as the Earth. They knew about this. There's no need to be a rocket scientist to find out the number of the days and seasons. If we have a number, if you put a tree or whatever to cast a shadow, from the length of shadow, we can find out exactly the time of summer solstice or equinox or winter solstice, and then count the number of days and repeat it every year, and you will find the exact numbers that I already explained. In fact, these are the things that